Hey, hey. Hey, NgIndia. Hey, NgIndia. Woo! Here we go, here we go, here we go. I know we've been through a lot of talks. It's a lot of content, but let's keep you awake because you'll need to be very much awake for the next half an hour. I'm going to provide you a ton of content, and hopefully you can be, using it in the future as well. I know it's like almost, 3, 4 o'clock in the morning where I'm from Toronto, and it was a very short 15-hour flight here. Yeah, let's, despite me falling asleep, let's keep you all awake. All right. So thank you for the introduction. I'm Alex Okrushko, Principal Architect at Cisco, part of NgRx team, Angular GD, and Angular Toronto organizer. And you can always find me on Twitter, for example, at Alex Okrushko. Very easy, matches my name. Okay, so we're going to talk about ComponentStore and its use cases. But before that, let's see who actually is familiar with some of these things. Who has heard about NgRx in general? Raise your hand. All right, so I'd say most of you, right? You have to be really living under a rock somewhere to not hear about NgRx. Who's using a global store, the NgRx/store? Who's using it? Okay, yeah, majority. And in fact, that's one of the most popular, well, it is the most popular state management library for Angular applications. I use one in every 6th application or so. ComponentStore. Who has heard of ComponentStore? Okay, less so. That's fair. And anybody's using it already in their apps? Okay, less so. Okay, good. So you're in the right session. I'm going to first talk about what ComponentStore is, and then I'm going to show you how to use it and some of the use cases where you can apply it in your apps. So ComponentStore. ComponentStore is a state management library. Yes, another one from the NgRx team. We have the global store, which is NgRx/store, and we have a ComponentStore, a more simplified state management library that has particular use cases. In a nutshell, it's a single file with 436 lines of code. I checked today, right? Like that's, in a nutshell, that's what it is. So it's small, independent from the global store, and hopefully simple to use and be very useful for your applications. All right. It's been around for now 2.5 years, and it's been getting a lot of traction. In fact, you can see here it's a green line. As of this week, it gets 160,000 downloads a week. And it's one of the most popular solutions out there for state management in Angular. In fact, it's the second most popular state management library, only, of course, after its bigger brother, the NgRx store itself, which is right there on top. You can see the red one. Anyhow, so you see it's getting some traction. And you might be asking, like, you have one, you have the other one, why do I need two, and all of this? Let me go over some of those cases. All right, so let's see what the NgRx ComponentStore is. As a state management library, it needs to do few things right. It needs to be able to read the state. It needs to be able to write the state. I mean, it's a state management library. And one other and very important thing, it needs to be able to handle side effects. So in the ComponentStore, we can read with the select method. We can write with the updaters. And for side effect, we have effect methods. Let's go over a very simple example, how we would typically write our ComponentStore. So the first thing we'll do is we'll declare an interface. And this interface is this state that this component store would be responsible for. In the component stores, we typically try to, because you can have many of them in the app, unlike the global store. That's why the component store typically owns a very small part of the state and is very much laser focused on what exactly it owns, right? And in this case, for example, we say that this component store will own which cart items we have. So it solely owns that state and that state only. So we'll declare this interface. Then we'll create a class. In this case, it will be injectable and provided in root. And that class will extend component store. And in there, you see we're passing that interface. So we're saying, hey, component store, so for you to be aware, this is the state that you'll be working with, right? And all that does is now all your functions, methods, and everything else become fully type safe. One thing that we take, really good care of within NgRx and put a lot of attention is type safety, performance, and then testability testing. All of those things are extremely important for us as a team. So then in the constructor there, I would say that, hey, this component store will also inject, say, cart service. And cart service in this case would be, your wraparound HTTP client to actually fetch some items, for example, from the cart. So we'd provide the injectable the same way we always do. In this case, also we have a super call. This is where we can define the initial state for this component store. In this case, we say, hey, initially it'll just be empty array. We can define it, or we can define it later. We can defer it later. We can lazily initialize it too. It's up to you how you want to do this. But you have options. All right, so this is initializing. Now, let's see how we would read the data from the state. We read it with the select method, right? Because we extend component store, it just comes free to us. And for example, here you see cart items. We select from the state, right? Select method describes how we extract data out of it. You see those error function, right? This is how we extract the data. For example, given the state, the cart items would be, state.cartItems. That's how we extract it. And what this gives us is an observable of cart items. The second line there you can see is cart items count. It shows you that we can also use select for other things like combining values or further deriving state out of other observables. For example, if we select and say, hey, given this cart items, use some function like reduce cart items to count as a function that will reduce that array to a single number, right? How many items there are in this cart, for example. So it also allows us to performant way, get the items out of there. So how we would use it in our component? Well, you can inject cart store as a regular service, and then this cart store dot cart items count would be your final value that you'll be consuming as a consumer for this component store. All right, so this is how we would read the data. How can we update the data? For that, we have, again, an updater function. And again, in the body of that function, we'll explain how we transform the data into the final state. For example, given the state and new cart items, which is the second argument there, we would spread this previous state and update the cart items in our state. Right? So now set cart items, although it looks like a property, right? It's actually a callable property. You can think of it as a method. And if you can see down below, highlighted below, the set cart items is called as a method, right? You pass cart items to it. So it's like a method. And whenever you call it, and every time you call it, it will invoke this updater. It will use your current state and use the argument that you pass to it, which will be the second one, and it will update the state. So this is how you update the state. Now, let's look at the final piece. Again, very important piece in my mind. In fact, this is the piece that enables us to handle all the race conditions and the applications. Something that we cannot do in Angular, like with the built-in stuff. So add product is an effect. And this effect, let's break it down. This effect is also a callable property. So you can think of add product as a method that you'll pass some argument to. Now, what are we passing to this add product? We'll get back in a second. But, well, I actually can tell you immediately. Every time we add product, we'll call it with the ID, right? So we'll pass like, add this product ID, for example. And what it does internally is transforms that into the observable. And then now you are, as a developer, fully in charge how to handle those race conditions when multiple add product IDs are called all the time throughout your application. That's why it turns into the observable stream, right? And you can see as the argument in this effect, it's like, hey, given this ID's observable stream, what should I do? And in this case, we would say, okay, IDs let's pipe, and then we'll use concat map here. And then using the concat map, we're saying, hey, given this ID, call the card service add product ID. You might notice I use the concat map. But there are other operators as well. Anybody knows any other ones that are also like helpful for race conditions? Not quite. Merge map, yes. Concat map, merge map, exhaust map, and switch map. Yes, that's right. Those are four. And those, knowing those four operators is crucial for any race condition handling. If you're doing NgRx, you must know these four operators. All of them do data transformation. All of them do handle those race conditions in particular ways. For example, concat map, what does concat map does? Well, imagine you have ID, right? Somebody called add product 1. And somebody calls at the same time add product 2, right? Different IDs. One comes in here, right? And it starts calling the card service to actually add the product. And usually it's a HTTP call, so there's some latency involved there. It's a synchronous process. And now the 2 comes in. What do you do? Well, with the concat map, it actually says, okay, I'll wait until the first one is done and only then do the second one. This ensures concurrency is completely fine. So that basically makes it sequential. If you don't want sequential and you want to start working on the second one immediately, you can use merge map. If you use merge map, 1 comes in and starts to make HTTP call, 2 comes in and starts making the second one in parallel. Right? That's the big difference between merge map and concat map. Now, there are other use cases where the first comes in, oops, yep, there you go, signal, get signal back. Let me just turn it off and turn it on again. That's always helps. There you go. I guess I was too long on the slide. Now, switch map, what does switch map do? Right? It starts the new request. If the second one comes in, it cancels the first one if it's still in progress and starts the second one. Right? So that basically cancellation of a request. Exhaust map does the opposite. Right? If exhaust map first request comes in, it starts working on this. The second one comes in, it's like, okay, I'm already working on something, forget about, right? It cancels this. Those are super critical to remember and to know, to understand in any RxJS project, Angular project, and especially the ones that uses NgRx. All right, so then we talked about this. And this is exactly why we have effect, to be able to control this. This is exactly why we turn those add product calls into observables, so you can explicitly define how you want to handle these race conditions. All right, so once we add, call the backend and add that, right, we have a result, right? And what we can do, again, we have tap operator. In the next call, we'll set our items, right? We'll call that updater that we just defined before. And in there, we'll, for example, update the error as well. And then we catch error as well, because we don't want this effect to collapse, and do the empty. This was a very popular pattern. So we actually created a custom operator called tap response that does exactly that, but in a safe way. First one is if it's a successful result, we'll set the car items, and if they are, we'll call the second callback. All right, so this is the read, write, and effect. Oh yeah, by the way, let's see how we can call this effect from our component. For example, we have the add to cart method on our component. For example, on click button, right? And it would have this product ID. And you can see here, right, we injected the cart store, and we're calling add product. But again, I'll try to draw your attention. We're not passing an observable. We're passing a single product ID, right? And this is every time we click, it'll push it into that observable queue within the effect. And this is how we bridge some of the non-reactive APIs of Angular. I mean, this is really a callback, right, to the reactive state management. All right, so this is very much how to use ComponentStore, how to create ComponentStore. It's APIs. It's very nice to know, and again, it's been around for 2.5 years, so some of you might have known that already. But how can you use it? What are the actual use cases of the ComponentStore? How can I use it in an application? Well, as I mentioned before, unlike the global state management, like NgRx Store, you can have many instances of component stores at different levels as well. All right, so we'll see this one. We'll see 4 use cases: singleton state, common component state, local component state, and a component branch state. And for that, I'll show you it on the app. We'll see this piece of app, but let me see it actually running. This is our book collection. This is our book collection. It's actually an example app that's part of the NgRx repo. But I've done some modifications here to demonstrate all 4 use cases for ComponentStore. Okay, we use the password 1234, right? Good, logged in. And then we go to this page. And this is the page of interest for us. What we see here is I have a language selector, which I can change to different languages. And I can start typing to search for a particular book titles. What it's using under the hood Google Books APIs, and we'll pull off what all the books are available for that particular title. So, for example, let's search for Angular. Angular, that's a lot of R, hang on, Angular, right? So, it gives me a result in the language that I chose. It gives me give me 10 results, right? 10 results. If I want to have more, I can click next button, right? It'll be 20 results. If I want 40 results per page, you'll see more like this, right? Multiple results per page. So it basically reacting, and if I type something else like TypeScript, for example, right, it immediately searches for new results. Now, if I change the language, for example, to say Hindi, nothing changes immediately, right? Because I don't know what kind of query I want to do first, right? So if I actually search for Angular, there's not much. That's not much. I was actually surprised. Not much, no. No, not much, not much. And I was talking to DJ, like, hey, is a Google API broken or something? He said, no. You have to, it says a lot of the content for Angular in India is still written in English. So when I switched back to English, and here you go, just find some books by DJ, by the way. So here it is. So basically, this is how you use it, right? And what's interesting, you see this this paginator. It's a custom-built component. It's not Angular material one. It's a custom-built one, and I'll show you some of the inner workings of it. But it's fully aware what it is. For example, see, we're on page 1 right now. You see the previous button or first page button, they're disabled, right? And if I switch to like 10 results, right, it's also aware of this. And in fact, when I do change the result, how many items per page I want to see, it updates everything, it calls again the APIs and fetches the data. All right, so let's break down this page a little bit further. Here you go. So this is basically how a page looks like. We'll break it down into the components that are part of this page. So the overall page has 2 major components. First part is a toolbar. It's independent, right? It's a larger component. And that toolbar has the language selector as part of the toolbar. Then you have the main page. This is the find book page. Find book page in itself has the book search, right? That's the area where we type and search for something. And it also has the paginator itself. Now, below you see the book preview list, right? That's the other component that has all the list of those book previews. And it basically goes and does the NG for like book preview, right? So those are the smaller components. And that's pretty much as granular as we're gonna go. So this is the basic structure. We'll see the same structure, but in the tree structure way. When you typically create your design docs for new features, you always create the tree structures to explain to your teammates how you want to structure your new feature. So you'll always create something like that, right? Right? Yes. Good. If you don't, please do. It's actually a really awesome way to share your features or design docs before implementation. So you'll share with your teammates how you want to structure things, where you want to reuse things. Anyhow, this is basically a tree structure of components. And we'll see where exactly we'll be adding some of those component stores. Okay, so we'll start with the singleton state. Singleton state. And that's the easiest one. And it's actually probably my least preferred use case for component store. And the reason for that is, we'll add the language store, for example. This is a component store that fully owns current language selected in the app. And what's notable and what makes a singleton state is that it's provided in root. Because it's provided in root, I can inject it anywhere in the application and read the data from it or set the data for it as well. But it basically becomes available fully in the app. It becomes almost like a global state. And that's why you probably see why it's not my most preferred way to do this, is because for me, for the global, means application-wide, shared state, I prefer NgRx store. And then I'll use component store for the other 3 use cases. And in fact, in most of my applications, but I work on the, quite complex enterprise level applications, I would use both the global store and the component stores. Global store will have the larger shared state, and then once I get closer down to the specific nodes, I'll have component stores in them. But anyhow, this is one of the use case. And language selector, for example, injects it and sets and reads the current language as well. All right? Provided in root is what makes it singleton state. Good. All right, let's see the second example, second use case. So my paginator is a common component. What makes it a common component? What does it mean when you say common component? Yes, what it means is it could be reused anywhere in the application. That means that it cannot really rely on any services to be injected into this. How it operates is with inputs and outputs from the parent component. That's how it talks to it. But paginator can still have its own business logic. And for that business logic, I'd like to outsource that business logic into the component store. So it will have its state and the business logic how to deal with this in the component store there. So for example, in this case, paginator store will have a few things that it tracks. It tracks which page index you're on, what's the page size, what's the length of it, and what are the page options, meaning like you can switch from 5, 10, or 40 books per view, right? So basically, once I log in again, here you go. Once I search for something, Angular, for example, right? My paginator component completely doesn't care that it's the books it deals with. Does not care at all. All it cares is like it deals with some items. And it knows how many items I can do per page, what page we're on, and based on its state, it tells me, hey, should my next button be enabled or not? Whenever I interact with the component, this component, it will let the parent component know, hey, they pressed the next button, and the next button means that they want to see the next like 40 books or whatever, 40 items that it's tracking. It has no idea what it's tracking, right? Because it's a common component. And in this case, page index, page size, and page length is what it does. Let me show you actually the paginator store itself. I'll show you the paginator component. Oops. Let me see, paginator component itself. There you go. See that my paginator component, it uses the paginator store, but what it does through any of the inputs, it basically immediately outsources all this work to the paginator store. Output, whatever paginator store provides, is actually then provided to the parent component. Then it generates the view model for internal itself, right? Should the next page be enabled or unable or not, right? For example, next page plus previous page, range label as well, right? It needs to generate all of that. And then whenever I change something or click something, it basically lets the paginator store know. See how simple this component is? It's literally 60 lines of code. And then all the heavy lifting, a paginator does itself. The beauty of component store also is that you can declare what are your triggers are changing what. So you can say, for example, let me see, for example, here. What does has previous page mean? What does it mean to have previous page or not have previous page? Well, it means it depends on two things. It depends on the page index and the page size. If page index is bigger than 1 and page size is not 0, then it has previous page. Or has next page, similar idea. Range label. Range label is this one, for example. What does this data, what data does this need to display this label? You can say, hey, it needs page index, page size, and length. Out of that, it will create me a string, right? And then the view model aggregates all of those different selectors and provides it as a view model to the component itself. There you go. Now I have this view model, and then in my template I'll just async pipe this and read all the properties from it. All right. There you go. So this is the paginator and the paginator store. The cool thing is, this example and the rest of the two examples, they do not provide in root. They provide for this component specifically. And what that means is, that means multiple things. In this case, it means that with every instance of paginator, they have its own instance of paginator store. That's why you can even have multiple paginators on the page. I mean, if your UX does this, but it could, right? And they're self-maintained. All right, so now that's the second use case. The third use case is local component state. And again, we want to outsource the business logic outside of the component into, say, your book search store in this case. That means the way I think about components typically as function over state that produces some template, and then when the user interacts with that template, it just produces some outputs. Thomas was talking about the mental models. That is my mental model for component. A function over some state that produces the template, right? Once that clicks, you're like, oh my God, who has 1,000-line components here? Plus, 1,000-line plus. All right, don't be shy. Don't be shy. Okay, yeah. I think many of us seen those, and those have become extremely unmaintainable. You want to remove the business logic outside of the component. It's easier to test and easier to maintain as well. So, book search has the book search store that maintains its state and all the business logic associated with this. For example, it reads the outputs from that paginator and then does something to it. And now it's fully aware of the context around this. For example, book search store keeps track of page index, page size, and query title, right? So this is what we search for, query title. And notice this one is also not provided in root. That means that bookstore is provided for this component. This and children can read it. But in this case, children are not using it. That's why we call it the local component state. All right, so we see book search is reading this. Finally, we'll have a larger state. We'll call it a component branch state. What does it mean? Well, that means that this state could be read by this component and or its nodes as well, right? So sometimes you need to unite them. For example, bookstore is the only store here that is fully aware which books we loaded. So you see, it owns books, 100% owns books. Nothing else duplicates that state. Everybody will be selecting from that. See the books? It also knows about total books. Because, for example, when we call an API for a search, we get only a limited set of books. For example, we ask for 10, it'll give us 10. But it also give us, hey, you get 10 out of like 360, right? So that's the other thing that it's aware. And of course, during any API calls, there could be errors. So we want to kind of keep track of the error as well. So bookstore is the only place here that is fully 100% owns books data. Everything else would be reading from this. And in fact, book search store will be reading that data for total books, so I can pass it further down. Book preview list would be reading this as well, because it needs to know about like the books to display, right? So this is a branch state. That state is available from that node and down into different components. So that's a branch state. So that's a little bit of theory. Let's see how they operate with each other. Some of the use cases. And we'll start with the simplest one. So this is I call it state flows, how the state flows through the application. We'll start with the simplest one. When language selector, your user selects a different language, right? So language selector has this drop down there, and it will change the language code. And language store is connected to it, right? So once the user does this, language store gets updated, and the language store gets updated, right, with the language code. That's it, nothing else happens. And this is by design, right? We don't want to do the new search when we just switch the language. Nothing else is reacting, nothing else needs to be done. Awesome. Let's see the next example. When user types. For example, they produce the new query title. Query title, that input, gets updated. So that component sets it to its state, and book search store owns that state. It's like, hey, query title, get updated. And now, after that component does nothing else. All it needs to do is to tell its store, hey, update this. And now, book search store uses that as a trigger. It's one of its triggers, like, oh, I know, whenever that changes, I need to do something. And what does it do? It takes the query title, takes the page size as well, and page index, just in case. It's like, hey, given this new information, because one of them changes, all of those three are my triggers. It calls the bookstore. He's like, hey, these things changed. Do something about it, because that's the effect. And that's it. It does nothing else. It just tells the bookstore, hey, these things changed. Bookstore like, oh, okay, I know this, but I also need to know the language. So it reads the language, combines all those four into something that it needs to do the query for the search books. And with all those four information, it calls new API saying, hey, given this language, this is page index, I need this many results, and this is the search term we're looking for, right? Do the search. It does the search, gets the result back, and results it gives like, hey, these are the books I found for your search, and by the way, this many of these books, right? So it gets the books in total, and updates the bookstore. Now, book search store is like, oh, I'm listening for the total books. It's like, I care about that data. Since it changed, it reacts to this, right? It's like, hey, I need this information, and passes it back to this book search. Now that's like, oh, okay, I need to actually pass it to the paginator. So paginator is like, hey, here's your new length. It passes to the paginator, and it updates the length in here, right? So that's all things are 100% reactive. Nothing is telling what to do what. All is saying, I'm interested in this data, I'll read it. Or do this when these triggers happen. Now what happened with books? Well, there's another component, find books page, that's interested in them. Because of that, it passes it to the book preview list. It spreads to the books with the NG4, and books information gets out. The whole thing is 100% reactive. And yeah, I'll give you just one quick example in the code, for example. In the book search, right? So I kept saying triggers, right? Let me just bump size a little bit. Whenever any of these things change, which is the entire book search state, it will trigger the search effect. And then, so that basically, if the page index changes or the query will search for a new item, it'll all happen. It'll debounce. It'll filter that the query is not empty, because we don't want to search for empty queries. And then it will call the bookstore inside and update some of the data. That's what I'm saying, triggers. 100% all done reactively. Let's see one more example. If I click the next page, what happens? Well, what happens is the page index changes. We change it from whatever, x to x plus 1, right? So we update the page index. Paginator outputs it through the outputs, like, hey, book search, something happened, here's the output. Book search will update it inside its own state. It's like, oh, it's actually page index, right? Page index gets together the rest of the triggers and sends it to the bookstore. Bookstore calls it needs language code, it reads that as well, calls the new book search, gets the books and total books, gets the data down, and you've seen this before, it just all goes down and everything that needs it data, reads it automatically. That's the beauty of it. I didn't have to do anything extra for it because all the triggers were all the same, most of it. Length and all the go down. All right, so that's some of the state flows with this application. Now, we talked about these 4 use cases: singleton state, common component state, local component state, and component branch state. Those are the 4 use cases that we as an NgRx team identified as very helpful, and different almost patterns, different mental models for how to use the component store. Because whatever you do, most likely they'll fit in one of those 4. Right? And it becomes easier for you to even communicate with your team members, hey, I'm creating this component store for this component, and it would be the branch state. It will own the books for the whole thing there. Or hey, this is actually the local component state, meaning that your children won't be even listening to that because through the dependency injection graph you can actually get to it, but it's not what it's meant to. It's meant to 100% just outsource the business logic and state outside of the component to the store. So it gives you basically a vocabulary to talk to your team about. These all examples are in this link if you want to. Yeah, right there. If you want to take a picture, I'm going to send it as well after. You can read more about the component store at the NgRx IO guide. One thing I wanted to mention about, by the way, when I was talking about the state management libraries in general, while NgRx is, the global store is the most popular solution, component store is now second most popular. For me personally, as long as you're thinking about managing state and using any other, maybe potentially state management library, it's already a huge win, and thank you for doing this. Be it like any other framework or library you want to use. So that's one thing I want to say as well. All right, so Michael was talking about signals today. Very nice presentation, Michael, thank you. Is NgRx doing something with signals? Yes, we do. And in fact, Marko Stanimirovic, one of our NgRx core team members as well, already has a prototype for component store that is fully signal-based. It's really awesome, we love it. We're working on polishing on this, but a lot of work already done by Marko. So stay tuned. There's probably more coming there as well. And one other thing I wanted to mention is NgRx recently got the enterprise support. What that means? Well, it means that select team members from NgRx are actually providing enterprise support, paid for support, to help with NgRx or NgRx trainings, or even your code architecture analysis. We can also do for like paid services. If you want, please contact us over there. All right. Right there. There are Discords. There's, I don't know if you use Discords, but there's a Discord GG Angular. This is official Angular Discord. It's over 30,000 people there chatting, asking questions about Angular. So please do join. There's also one for NgRx if you have NgRx specific questions. But even the global one, the main Angular one, it also has NgRx questions. You can tag your question with NgRx and somebody will most likely get to it. And finally, I have a bunch of NgRx stickers right there in the front. So if you want some, please do grab some. They're all nice and shiny, as you can see here. Yeah, please get some. And thank you so much, Alex.
That was awesome.